Hello, welcome to our CompTIA Security Plus course. In this lesson, we're going to talk about the physical security controls, covering perimeter security, internal security, equipment security, environmental controls, and secure data destruction. So when planning security for network scenarios, many organizations overlook physical security. In many smaller organizations, the placement of servers, switches, routers, and patch panels is determined based on space restrictions, and equipment often ends up in odd places, such as in the coat closet, by the receptionist desk in the lobby, in the room with a copy machine, or in a storage room with a backdoor exit that is unlocked most of the time. Securing physical access and ensuring that access requires proper authentication are necessary to avoid accidental exposure of sensitive data to attackers performing physical profiling of a target organization. Physical access to a system creates many avenues for a breach in security. Unsecured equipment is also vulnerable to social engineering attacks. It is much easier for an attacker to walk into a reception area, say he or she will be there to do some work on the server and get access to the server in an unsecured area, than it is for the attacker to get into a physically secured area with a guest sign-in sign-out sheet. In a secure design, physical security controls parallel data controls. When it comes to physical security, the most obvious element to control is physical access to systems and resources. Your goal is to allow only trusted use of these resources via positive identification that the identity accessing the systems is someone or something that has permission to do so, based on the security model you have chosen. Sections, we're going to describe physical security components used to protect the perimeter. So the first ones are signs, fencings, and gates. So some organizations are bound by regulations to warn employees and visitors about workplace hazards. One of the most common ways to accomplish this warning is to use what we call as signs. Warning signs can be both informative and deterring. For example, if an organization deals in caustic chemicals, signs warning of the chemicals can inform visitors while also deterring intruders. Agencies such as OSHA or OSHA or Occupational Safety and Health Administration, ANSI, American National Standards Institute, and NEMA, National Electrical Manufacturers Association, have established specifications for safety signs. A common deterrent is a fence or a similar device that surrounds an entire building. A fence keeps out unwanted vehicles and people. One factor to consider in fencing is the height. The higher the fence, the harder it is to get over, To deter intruders, fence height should be 6 or 7 feet. For areas that need to be more secure or to provide protection against a determined intruder, the fence should be 8 feet tall with barbed wire on top. Another factor to consider is the fence material. Removing wooden slats or cutting a chain link fence with bolt cutters is much easier than drilling through concrete or block. Keep in mind that if the fence is not maintained or the area around it is not well lit, a fence can easily be compromised. Another form of fencing is data center cage fencing, a secure cage that provides an additional physical security layer. So where fences are used, gates usually control access through the fencing. They can be staffed or unstaffed, and one of the main advantages of using automatic gates is the capability to use keycard readers and touchpad systems to control entry and exit. Unstaffed gates allow entry only to people who have clearance to enter an area. An additional benefit of using an automatic gate with keycard readers is that the system maintains a log of all the area entries and exits. Hybrid staffed and automatic systems use a feature that checks entry via intercom. The gate can be opened when verification is complete. This type of system is often used for visitors and outside vendors. The next part of perimeter security is lighting. So from a safety perspective, a too little light can provide opportunities for criminals, and too much light can create glare and blind spots, resulting in potential risks. Protective lighting improves visibility for checking badges and people at entrances, inspecting vehicles, and detecting intruders both outside and inside buildings and grounds. Protective lighting should be located where it will illuminate dark areas and be directed at probable routes of intrusion. Proper placement and positioning of fixtures can dramatically reduce the glare. In areas where crime is concerned, install lamps with a higher color rendering index. Bright lighting and cameras reduce the likelihood that an area will experience unauthorized access attempts. A good design provides uniform lighting, minimizes glare, is compatible with CCTV, and complies with local light pollution and light trespassing ordinances. Regular maintenance ensures that the safety and security of both people and property are not compromised. It should at least be twice annually. You need to conduct an audit of all exterior lighting. The third one are barricades. So, to enhance the security of critical or vulnerable facilities, physical access control structures, or barricades, can be used to protect against unauthorized people, vehicles, explosives, and other threats. Barricades provide a high level of protection and can withstand direct impact forces. Vehicle barricades often are used in restricted areas to stop a vehicle from entering without proper authentication. A common barricade in many environments is a bollard, right? So a bollard is actually a short post that prevents vehicles from entering the area. Crash-rated barriers and bollards provide the best security but can be costly. Other examples of vehicle barricades include drop-arm gates, active bollard system, planters, and crash barrier gates. Now the fourth one are cameras, right? Cameras and CCTVs are commonly used for perimeter surveillance. The video signals is processed and then transmitted for viewing at a central monitoring point. Traditionally, CCTV has been analog, however, recent technologies have taken advantage of the digital format, including IP video surveillance that uses TCP/IP for more remote or wireless recording and monitoring. CCTV is a critical component of a comprehensive security program. It is important to appropriately plan and set clear, measurable objectives for CCTV systems. Failing to do so from outset can be quite costly. And the last component of perimeter security are security guards. The presence of security guards can be reassuring to employees and can discourage intruders. Security guards are often armed, and they must be trained properly. The range of duties for guards can include staffing security gates, checking credentials, conducting active patrols, and monitoring CCTV feeds. Guards tend to be a greater visual deterrent than cameras alone and are often used in combination with other measures such as deterrent signs. Now let's talk about internal security. So mandatory physical access controls are common in government facilities and military installations where users are closely monitored and are very restricted. Because they are being monitored by security personnel and devices, users cannot modify entry methods or let others in. Discretionary physical control of a building or room is delegated to parties responsible for that building or room. So here, internally security guards, right? Surveillance cameras, motion detectors, limited access zones, token-based and biometric access requirements for restricted areas, and many other considerations can be involved in physical security planning. In addition, users must be educated about each measure taken to prevent circumvention and improve ease of normal access. Now, so the following topics here or sections briefly will describe physical security components used to protect an organization when a person gets past the perimeter of the property. So the first one here are alarm systems. Alarm systems detect intrusions and monitor or record intruders. Electronic alarm systems are designed to detect, determine, and deter criminal activity or other threatening situations. An alarm system can detect an event such as an invasion, a fire, a gas leak, or environmental change. Determine whether an event poses a threat, then send a notification about the event. Alarm systems can also be combined with CCTV surveillance systems to automatically record the activities of intruders. Alarm systems can also interface with access control systems to electrically lock doors, like for example. Next are motion and infrared detection. The main purpose of a motion detector is to provide security against intruders by alerting security personnel to an unexpected presence or suspicious activity on the company premises. A motion detector contains a sensor that is integrated with other technologies to trigger an alert when a moving object is in the sensor's field of view. Motion detectors can be based on light, sound, infrared, or ultrasonic technology. In addition to motion sensors, other sensors are available for detection of motion, noise, proximity and moisture, temperature, sound, fire, steam, vibrations, tilt, and touch. Even inexpensive off-the-shelf computer technology such as the Raspberry Pi can easily integrate with different types of sensors. And the third one are access control vestibules. An access control vestibule is a holding area between two entry points that gives security personnel time to view a person before allowing him or her into the internal building. One door of an access control vestibule cannot be unlocked and opened until the opposite door has been closed and locked. In the most basic implementation of a man-trap, one door connects to the non-secured area and the other door connects the portal to the secure area. Access control vestibules are often used to prevent tailgating and used in areas such as data centers. Man-trap doors are operated mainly via radio frequency identification or RFID cards and can be sophisticated enough to record a person's weight coming in and out, for example, to trigger an alarm if the person might be taking equipment from the data center. And the last one is locks and lock types. So locks must be easy to operate yet deter intruders. Beyond the normal key lock, several different types can be considered. A cipher lock has a punch code entry system. A wireless lock is opened by a receiver mechanism that reads a card that is held close to the receiver. A swipe card lock, such as those in hotels, requires a card to be inserted into the lock. Factors to consider related to locks are strength, material, and costs. Now let's talk about equipment security. The next layer of physical security is the security of equipment. Physical access to a system creates avenues for security breaches. Many tools can be used to extract password and account information, but can then be used to access secure network resources. Given the capability to reboot a system and load software from a USB drive, attackers might be able to access data or implant Trojan horses and other applications intended to weaken or compromise network security. A more serious threat is theft or loss. Laptops and handheld devices are easy targets for thieves. Theft of laptops and handheld devices in an office setting is nearly as high as theft in cars and other forms of transportations. To prevent theft or loss, you must safeguard the equipment in your organization. So let's talk about the first one, which are cable locks. To protect organization resources and minimize liability costs, each employee should take responsibility for securing office equipment. Laptops should never be left in an area where anyone can easily access them. Laptops, Apple iMacs, and other easily transportable office computers should be physically secured. Security cables with combination locks can provide such security and are easy to use. The cable is used to attach to the computer to an immovable object. Computers have one and sometimes two security cable slots. The security cable slots allow you to attach a commercially available anti-theft device to the computer. Now let's talk about cages and safe. Tower-style computers can be targets for thieves not only because they have higher resale value than laptops, but also because of the data they might hold. For example, financial businesses have been hit hard by theft or desktop computers that hold a lot of personal data. Secure computer towers and server cages that are bolted to the floor can improve physical security and prevent theft. In machines that are bolted to the floor, drive access can be either completely restricted or left available for ease of use. Server cages are often found in the data centers to protect server equipment and separate customer equipment. Co-location data centers can host the information of multiple customers, and a standard data center cage made of rigid metal is typically used. Cages can be modified based on the customer's specification, such as stronger locks, restricted backside access, or military-grade requirements. Locking cabinets and enclosures. A locked cabinet may be used to hold equipment that is not in use or that does not have to be physically accessed on a regular daily basis. Enclosures are a common form of locking device, more appropriate for data centers, where the system are still active but can be locked away in an area that is adequately cooled. Vendors provide solutions such as security cabinet enclosure to secure CPU towers and server blades. The housing is made of durable, heavy-duty steel for strength that lasts. The sides and doors are ventilated to reduce the risk of overheating. Next one are screen filters. A computer privacy screen filter might be a requirement depending on the type of business an organization conducts. For example, HIPAA or HIPAA has stringent standards for patient privacy protection. It requires medical insurance and other healthcare businesses and practitioners to protect the privacy and security of medical information, including information that is visible on the computer screen. A computer screen filter limits the reading radius of the screen so that someone looking at the screen from the side cannot read what is on screen. Many organizations require screen filters to shield important documents. In addition, privacy screen filters are often used by employees while traveling to protect information while sitting in airports, using public transport, or working from the other public places. Privacy screen filters can help prevent shoulder surfing. And the last one are air gaps. An air gap is a physical isolation gap between a system or network and the outside world. With an air gap, no system is connected to the internet or connected to any other systems that has internet access. In a true air gap system, data is transferred to the system via removable media or direct connection to another computer. Air gaps prevent unauthorized access and keep malware away from the system. Air gaps are often used in industrial control systems, military classified networks, and credit and debit card payment networks. Air gaps are used for highly secure systems, however, they can be and have been compromised in the past even though these systems are not connected to the internet. Perhaps the most high-profile case involving the infection of an air gap system is Stuxnet. So remember that an air gap is a physical isolation gap, right, between the system or network and the outside world. It prevents unauthorized access and keeps malware away from the systems. Now, let's talk about environmental controls. So here, not all incidents arise from the attacks, illegal activities, and other forms of directed threats on the enterprise. Many threats emerge from physical and environmental factors that require additional consideration in planning for security controls. The location of everything from a building to a wireless antennas affect security. When picking a location for a building, an organization should investigate the type of neighborhood, population, crime rate, and emergency response times. This information helps in planning the physical barriers needed, such as fencing, lighting, and security personnel. An organization must also analyze the potential dangers from natural disasters and plan to reduce their effects when possible. So what are the components of environmental controls? First is protected cabling, protected distribution, and Faraday cages. It is just important to take shielding into consideration, right, when choosing cable types and placement of cable. A coaxial cable was the first type of cable used in computer networks. Coaxial cable are made of thick copper core with an outer metallic shield to reduce interference. Coaxial cable have no physical transmission security and are simple to tap without anyone noticing and without interrupting regular transmission. So that's a coax. I'll put it here, coax. Next one are twisted pair cables. It is used mostly on today's network topologies, right? Twisted pair cabling is either called UTP or unshielded or shielded STP. UTP is popular because it is inexpensive and easy to install. UDP consists of 8 wires twisted into 4 pairs. Next one is the STP or shielded twisted pair. It's actually different from UTP in that it has a shielding surrounding the cable wires. Some STP has shielding around the individual wires, which help prevent crosstalk. STP is more resistant to EMI, or electromagnetic interference, and is considered a bit more secure because the shielding makes wiretapping more difficult. Another concept here are the plenum, which is the space between the ceiling and the floor of a building next level. It is commonly used to run network cables. The cables in this part of a building must be plenum grade to comply with FAR codes right? And the outer casing of this type of cable is more fire resistant than in regular twisted pair cable. Now, a more efficient way to protect large amount of equipment from electronic eavesdropping is to place the equipment in a well-grounded metal box of conductive material called a Faraday cage, like this one. It's named after the inventor, Michael Faraday, right? And this type of box can be small enough for a cell phone or can encompass an entire building. The idea behind it is to protect the contents from electromagnetic fields. The cage surrounds an object with interconnected and well-grounded metal, typically a copper mesh that is attached to the walls and covered with a plaster or drywall. The wire mesh acts as a net for stray electrical signals either inside or outside the box. And the last part are HVACs, right? They're called heating, ventilation, and air conditioning. So when doing facilities planning, you need to take into consideration the cooling requirements of computer data centers and server rooms. The amount of heat generated by some of this equipment is extremely and highly variable. Depending on the size of the space and the age of the type of equipment the room contains, energy consumption typically ranges from 20 to 100 watts per square foot. Despite being smaller and more powerful, newer servers might consume even more energy than older ones. Some high-end facilities with state-of-the-art technology can require up to 400 watts per square foot. These spaces consume many times more energy than office facilities of equipment size and must be planned for accordingly. Smaller, more powerful IT equipment is considered hotter than older systems, making heat management a major challenge. So when monitoring an HVAC system, keep in mind that overcooling causes condensation in equipment, and too dry environments lead to excessive static. Here, you need to monitor the area for hot spots and cold spots, ensuring that you don't have one exchange that is frigid cold under a vent and hot elsewhere. When water or drain pipes are located above facilities, it is important to ensure that upper floor drains do not clog. One solution is to use rubberized floors above the data centers or server rooms. Above all else, timely air conditioning maintenance is required. Some additional concepts here, like fire suppression, right? So fire is a danger common to all business environments and must be planned for well in advance of any possible occurrence. The first step in the fire safety program is fire prevention. So as you may know, fire suppression systems are rated according to class. First one is class A, right? So for class A fires like trash, wood, and paper, water decreases the fire's temperature and extinguishes its flames. Next is the class B. For class B fires, foam extinguishes flames fueled by a flammable liquid, gases, and greases. Liquid foam mixes with air while passing through the hose. Third one is Class C. Class C fires, which is energized electrical equipment, electrical fires, and burning wires, are put out using extinguishers based on carbon dioxide or halon. The third one or fourth one is Class D. So Class D fires are fires that involves combustible metals such as magnesium, titanium, and sodium. The two types of extinguishing agents for Class D fires are sodium chloride and copper-based dry powder. The last topic on the environmental controls, right, are hot and cold aisles. Data centers and server farms can have server racks be arranged with alternating row facing opposite or opposing directions. Fan intakes draw in cool air vented to racks facing the cold aisle, and the fan output, which is hot air, which is vented to the alternating hot aisles for removal from the data center. This data center organization provides efficiency in thermal management by allowing supply ducts to serve all cold aisles and exhaust ducts to collect and draw away heated air. Now let's talk about secure data destruction. Sensitive and privacy-related data, including log files, physical records, security evaluations, and other operational documentation, should be managed in an organization's retention and disposal policies. The policy should include specifications for access authorization, term of retention, and requirements for disposal. Depending on the relative level of a data sensitivity retention, and disposal requirements can become expensive and detailed. Now, the most prominent example of a security risk is a hard drive inside a computer that has not been completely or properly wiped. Some concerns about data erasure sufficiency in newer SSDs or solid-state drives might require organizations to destroy drives instead of simply erasing them for normal disposal channels. So with the secure disposal of equipment, a wide range of scenarios needs to be considered. First is breaches of health and safety requirements, inadequate disposal planning that results in severe business loss, remnants of legacy data from the old systems that might be accessible, disposal of old equipment that is necessary to read archived data, and theft of equipment in use during cleanup of unwanted equipment. Proper disposal of removable media is also important. An organization must properly handle removable media when the data should be overwritten or is no longer useful or pertinent to the organization. Generally, all electronic storage media should be sanitized or purged when it is no longer necessary for business use, as well as before its sale, donation, or transfer of ownership. Sanitation and purging is the process of removing the contents from the media as fully as possible, making restoration of the data extremely difficult. The following methods are acceptable for some forms of media sanitation. First is declassification. This is a formal process of assessing the risk involved in discarding information. Degaussing. This method involves using a tool to reduce or remove the magnetic field of the storage media. Wiping. This method, which applies to magnetic storage devices, writes over all data on the media and destroys what was originally recorded. And the fourth one is encryption. This method requires a strong key, effectively making the data unrecoverable without the key. The process can be combined with crypto shredding by purposely purging the key used to encrypt the data. There are also some additional methods of media and paper destruction that organizations or third-party organizations may engage, right? This includes the following. First is burning, right? Government organizations commonly use this method. Sensitive data is temporarily contained in burn bags and then incinerated. Next is shredding. Shredding, right? This commonly used method involves destruction using blades with varying degrees of effectiveness. Simple, low-cost solutions present problems because shredded documents sometimes can be reassembled. Third one is pulping. Pulping, this process involves dissolving paper, reducing it to its cellulose fibers. Organizations that provide shredding services often later pulp the shredded material before recycling it. And the last one is pulverizing. Pulverizing, right? Special systems that contain rotating hammers such as crush materials in high speed before passing them through a sizing screen to turn them into tiny particles or even dust. Right? So that's the end of the lesson. Here we spoke about perimeter security, internal security, equipment security, environmental controls, and secure data destruction. Thank you very much.